Okay, now I'm going to make use of the board and I need you to all pay attention. Okay, so we actually, I believe those of you online can see the board, right? Can somebody confirm if you can see the whiteboard? Those of you online.
Yes, we
Yeah,
can
we
see
can
it.
Okay,
see
thank
it.
you so much. Okay, so we have a normal density, okay, giving us what I have here. Okay, so we have normal density, the joint normal density, giving us what I have here. I'm going to tell you this. This we can also have a standardized, joint normal density. It becomes standardized, situation where mu1 equal to mu2 equal to 0, and the sigma 1 squared equal to sigma 2 squared equal to 1. So please take notes. So by the time I plug in all this value into the joint density, I have a standard joint normal density. Okay, now when you take a look at this, we go ahead. Are you talking about this one? Yeah, if you don't want to put it inside the square root, when it come outside, it becomes a standard deviation. Does that make sense? When it's inside the square root, it's going to be variance. So what is the square root of the variance? That will be standard deviation. That is when it becomes a standard deviation, it's no longer going to be in the square root. It's going to be outside the square root. Okay, so if you plug in all this, it's basically going to become that. Now, another thing is we derive the f of x1 given x2. We also derive f of x2 given x1. But from the f of x1 given x2, we need two things that you need to remember. Expected value of x1 given x2. If you take a look at that, expected value of x1 given x2, I'm actually going to have this row, okay? And of course, the variance for that also exists. So the variance, for that is going to be 1 minus that and sigma 1 squared. Now, from this one to expected value of x2 given x1 equal mu2 plus x1 minus mu1 sigma 2 over sigma 1 rho, and the variance of x2 given x1 is actually this guy. Please, I need you to take note of this. From the joint density, we have the conditional mean, okay, and the conditional variance from this as well. Please take note. Now, the very first question that I basically want to walk you through, okay, if you take a look at, the very first one here, I walked you through this yesterday, the probability of 2x1 plus x2 less or equal to 3. Okay, if you take a look at that, like I said, don't forget your W equal to that. So which means what you want to do now is this. All what you need is the probability of Z less or equal to W minus the expected value of W by the square root of the variance of W. Of course, all what you just need to do from here, you just find the expected value of W and the variance of W using what we've done before. Okay, so now I'll go to the third part of the question. In the third part of the question, the probability of S2 greater than 1 giving X1 equal to 2. Okay, this is the third part of the question. Now, when you take a look at this, this is, you actually is talking about X2 giving X1. Okay, so this is the X2 giving X1. We actually need the idea of, what we have here. Now, if you take a look at this guy now, okay, the probability of S2 giving S1. Now, if I basically want to figure out something like this, okay, I'm going to use the idea of a standardized normal distribution. Now, I'm basically need this guy, okay? I need this guy, and I need this guy in a way. So I want to find the probability of X2 greater than this. Of course, if I basically want to find this, it's going to be, I need the probability of Z. Now, what is this? Greater than, right? Greater than. Okay. Now, the value given 1 minus the conditional mean. What is the conditional mean? Okay. The conditional mean, you basically going to make use of this guy. And in the question, I think they gave you some information. Okay. They gave you some information. They gave you mu1, mu2. They're going to give you all the parameters in it. So what I'm expecting you to do is here, okay, the expectation of X2 given X1 divided by the square root of the variance of X2 given X1. Okay, do you see that now? So this one, okay, you're basically going to use this. They've given you the values. They've given you mu2 in the question. And what is your X1? X1 equal to 2. Okay, plug in. They're giving you all this. Okay, so you're going to make use of this here. Then what about variance of X2 given X1? This is what you're going to use. Plug in the values. You put that. Then the probability of Z greater than that, whatever you get, it's going to be 1 minus, if you want to go to the table, less or equal to whatever you get here. Does that make sense? Now you can see, I'm just trying to show you how we make use of all this. Very important. Look at that. Because it's talking about X2 giving X1. That is why I'm focusing on this. If they say X1 giving X2 is going to be this guy here, please take note. Very, very important. Okay. The last one that I'm going to do before I actually go to the midterm 2 pattern, okay, that I'm going to do before going to the midterm 2 pattern is, you are given a question, and that very question, they actually said, they said, given that I'm talking about, you are given this expected value of X1 given X2 equal 3.7 minus 0.15 X2. Okay. And they also gave you that expected value of X2 given X1 is 0.4 minus 0.6 X1. And you were given the variance of X2 given this to be 3.64. And the question they are asking you to find is, you are asked to find, okay, the expected value of X1, the expected value of x2, the variance of x1, the variance of x2, and they also ask you to find the row. Now, how can you solve a problem like this? This is what you are given. You're given this guy here. You see that? That is what you're given. Okay? Now, when you're giving this guy now, look at the first one. Expected value of S1 given X2. Where is that? This is it, right? Expected value of X1 given S2 is this, right? If I were you, what I'm going to do, I'm going to write this and equate it to this. So if I want to start solving that now, okay, I think because I need all this, I think let me clean the other side. I need all of that. Okay. Okay, so what I'm going to do is 3.7 minus 0.15 x2 equal, okay, what is the formula? Expected of S1, this one, I'm going to write equal to this, mu1 plus x2 minus mu2, okay, sigma 1 over this row. Okay, if I want to simplify what I have, this is more or less this plus x2 sigma 1 sigma 2 row minus mu2 sigma 1 sigma 2 row. Now, if you take a look at this, it has x2, right? Please focus. Okay, this guy also have x2, right? There's x2 here. What does that mean? I can deduce that sigma 1 sigma 2 row equal negative 0.15, equation 1. Okay, now mu1 and this, they are independent of the variable. I'm going to say this minus this equal 3.7. Okay, so I'm going to write mu1 minus mu2 sigma 1 sigma 2 row equal 3.7, equation 2. You see that? You see the way I actually work it out? Okay, now do you know that if that is what I got from here now? Now I just make use of this guy here. Okay, the same thing we applicable to expected value of x2 given x1. Okay, the expected value of x2 given x1, 0.4 minus 0.6 x1 equal, what is that? What is the expected value of s2 given x1? It is this guy here. Okay, I'm going to equate that. So it's going to be mu2. Okay, when I expand that, that is going to be plus x1. Okay, sigma 2 sigma 1 row minus mu1. Okay, sigma 2 sigma 1 row. Okay, now if you take a look at, if this has x1, this has x1, right? What does that mean? It also means that sigma 2 sigma 1 row equal negative 0.6, equation 3. Then the remaining part, mu2 minus that would be equal to 0.4. Okay, so mu2, okay, minus mu1 sigma 2 sigma rho equal is 0.4, equation 4. Okay, so take a look at all the equation now. You can see. Now, lastly, I want to make use of this guy. Okay, the variance of x2 given x1 equal 3.64 equal what? What is the variance of x2 given x1? It's right here. I'm going to write 1 minus rho squared sigma 2 squared. This is equation 5. if I want to begin to solve, okay, I can start my solution from anywhere. Now, if you take a look at if you take a look at equation 1 and 3, if I multiply this, if I multiply this by this, what is going to happen? This guy is going to cancel that. I'm only going to have a rho squared. Rho squared is going to this multiply by this. The moment I get a rho square, I can get a rho. Does that make sense? The square root of rho square is going to be rho. And the moment I get that rho, okay, if you can come back to equation 2. When I plug in rho here, okay, and another thing that is so by the time you combine all the equations, you apply your knowledge of math, you're basically going to figure out all of this. Okay, so this guy, expected value of x1 is the same thing as mu1. This is the same thing as mu2. This is the same thing as sigma 1 squared. This is sigma 2 squared. Okay, I just feel like, showing you all of this before I go into today's, so this is the, the significance of jointly distributed function cannot be overemphasized, okay, in the sense that, it enables you to figure out relationship between two variables. Not only that, you can also try to figure out the probability between what is the probability that x is greater than y, just like the example I cited yesterday. If x is a survival time, okay, of patients that were subjected to certain medication, and y it is survival time of another group of patients that were subjected to different kind of medication, what is the probability that the survival time, of one group is going to be more than the other group? Now, I want to talk about that one now. Okay, so another the the significance, another importance of if you want to consider joint distribution. Okay, now you want to find the probability of s greater than y. I told you the other time, I gave you an example yesterday. If you got two group of patients suffering from terminal disease and x, and the two group, you gave one group a combination of physiotherapy and chemotherapy, and the other group only received chemotherapy, and x represents survival times from those who receive both chemotherapy and radiotherapy, and y is the survival time of those who only receive chemotherapy. And you want to figure out the probability of s greater than y. If you want to figure out probability of s greater than y, the very first thing you're going to ask yourself, what is the name of the joint distribution I want to use? Okay, if we're told that x and y, if we're told the survival times, the two survival times are jointly distributed and they follow normal density. Okay, let's say they follow normal density. You know the meaning of this. It means I actually want to find this. Does that make sense? That's what I want to find. So if this is what I want to find, I can let w be x minus y, and what I'm actually going to be finding is the probability of w greater than 0. Then in that situation, it's basically going to be the the 0. Let me say this, or let me just say w minus expected value of w, because when they follow normal distribution, we're basically going to use the idea. Okay, we're basically going to use the idea of a standard normal. What are you going to do now? Your w is going to be 0. Then you need expected value of w. Okay, and the expected value of w is basically going to be this, right? Which is going to be what? Expected value of x minus expected value of y. Then you need the variance of w. Okay? You need the variance of w. The variance of w here is basically going to be the variance of x plus the variance of y minus 2 covariance of xy. Take a look at that. Okay? So here, you can see the application now. You can see the way it goes. Don't forget. Okay? So that is it. Okay, so that's going to be the end of all that. I want to go into